Okay, I want to show you guys how to solve this integral from my Instagram. We have the integral going from 0 to infinity of this thing right here. And let me tell you, this right here actually converges. Even though at 0 it looks like a trouble, and infinity of course looks like a trouble, plus 1, because ln1 is 0. Well, all those trouble numbers is actually okay. You guys can check the limits, but I'm going to just leave it for you guys. How do we deal with this though? Here is the deal. Whenever you see like a humongous integral, especially a definite integral, I think more than 90% of the time, do not integrate this by any of the typical method. Instead, you should try to use a property of integration and see what we can do. We will be using the integral going from 0 to infinity of a function. This is actually equal to the integral going from 0 to infinity of f of 1 over x over x squared. And how do I know to use this? Here's the hint. Whenever you have like 1 plus x squared on the bottom, and of course 0 to infinity, this is the big hint. Try it. And of course the natural log also have some nice properties that we can use later on. But shall we do a quick proof of it? Sure, let's do it. First, of course, but I'm not going to abuse the notation. I'm going to start off with a fresh marker. So we are going to say that x is equal to 1 over t, and then isolate the t is the same as 1 over x. And if you look at this and differentiate, you can say dx is equal to negative 1 over t squared dt. Now, take this into the t world. Have a look. The integral here. When x is equal to 0, if you put that right here, technically this is an improper situation, right? But it's really talking about the limit. If you put 0 plus into here, 1 over 0 plus is infinity. So t started at infinity. I know, we'll take care of that later. And when x is infinity, put it here, 1 over infinity is 0. And then f of x is 1 over t. Dx is negative, and that's a multiplication. 1 over t squared. Yeah, and then here's the deal. Have a look. We can use this negative to switch this and that. And that's one of the properties of the integral. So we will just have the integral going from 0 to infinity, no more negative, and we can write that as f of 1 over t, and then over t squared dt. Now, this is a definite integral. The output is just going to be a number. Therefore, the variable that we're using here does not matter. This is called dummy variable. So we can just go back to using x. I know t is equal to 1 over x, but again, this has the same value as that. Look at the structure, don't look at the variable. Alright? So now we can use this now. And to start, I'm going to first call this integral to be I, and then I'm going to write I in blue and use this property here. So have a look. I will be the same as integral going from 0 to infinity, and we will just have to plug in 1 over x into all the x's here. So we will have f, and let me just use the, well, we have a quotient inside of the ln, so we can split that, right? So this right here is the same as saying ln of 1 plus x is now 1 over x, and then raised to the 11th power, and then minus ln of 1 plus, same thing, x is now 1 over x to a third power, and then all over 1 plus x is 1 over x, and then squared, and then ln of 1 over x. And then don't forget we still have the 1 over x squared part, and then the dx. Okay. And we can simplify this a little bit. For example, we can get the common denominator right here. So that is the same as ln of x to the 11th power plus 1 over x to the 11. And likewise, this is the same as x to the third plus 1 over x to the third. And then use the log property to split this again. That's kind of cool. Let's have a look. So this is going to be the integral going from 0 to infinity. This is that, and split that, we get ln of x to the 11 plus 1 minus x to the 11 in that ln, and then minus ln of x to the third plus 1 minus, but with this minus it becomes a plus ln of x to the third power, like so, all over. We can take this, multiply with this and that, so they cancel out, which is nice. So x squared plus 1, and this right here is the same as x to the negative 1, so we can write that as negative ln x. Okay, this is the same as the original. Does it really help? Yes, have a look. Notice this part and that part match. We can break it apart, don't worry. Likewise, this part and that part match. Again, we can break it apart, don't worry. And in fact, this right here, we can bring the power to the front. So really, that's negative 11 ln x, and this is plus 3. So altogether, these two terms will give us minus 8 ln x. Okay, not so bad. And negative can be brought to the front. That's all. Now, here is how we are going to continue. I'm going to leave this right here, and I'm going to erase this right here. See? Here is the classic trick. We are going to add the original integral with like its alternate inversion and hope for the best. So we have the original one. I will put that in black, and then we're going to add that with the new one in blue. So have a look. We have this integral going from 0 to infinity. Break it apart, that's ln of 1 plus x to the 11 minus ln of 1 plus x to the third over 1 plus x squared and then ln x. Close that. And then right here, I know we are adding, but we have a minus here. So this becomes a minus. And then we have the blue integral here, which is the integral going from 0 to infinity, that and that, which is negative 8 ln x, and that, but the negative is right there already. Now what? On the left hand side, I plus I is just 2i. Now on the right hand side, both integrals are going from 0 to infinity, so we can just combine the inside, and it was super nice because the denominator is the same. So it will be just the integral going from 0 to infinity. Okay, we'll just have that denominator, which is x squared plus 1, and then ln x, and then dx. If we combine this and that, have a look, that's a subtraction. So this and that cancel. Perhaps let's do this, minus that. And perhaps to make it more clear, I will distribute the negative, so it becomes a minus here, and then plus here. And then that would be a plus, right? So we're combining them. So this minus that cancel. In fact, next one also cancel. We only have this. It's just plus 8 ln x. Guess what? The ln x cancel. Very nice. And now integrating this, we can first put the 8 in the front. And then 1 over x squared plus 1 is just going to be inverse tangent. And then we go from 0 to infinity. Plug in infinity, inverse tangent, when x goes to infinity, we get pi over 2. So this is 8 times pi over 2. And then plugging 0, that would be 0. So this right here is just 4 pi. But that's 2i equals 4 pi. So divide both sides by 2. I, the original integral, or the blue one, is equal to 2 pi. Yeah, just like this. So if you like this video, if you like the process of thinking and observing what's going on, if you like learning, then you also like today's sponsor, Brilliant.work. Brilliant is an online learning platform that helps you level up your math, science, and computer science skills through active problem solving. Brilliant isn't about memorizing formulas or watching someone else do it. You actually interact with the concepts step by step and figure things out on your own. It's like training your brain to think sharper, and it's really satisfying. I've been working throughout some of their courses, and even as a math teacher, I still find new ways to look at things. Whether you are brushing up or diving in, Brilliant makes it feel like you are solving puzzles, not taking a test. And they have tons of courses for you to choose from, ranging from basic math to advanced calculus. so they have something for everyone. Now, to try everything Brilliant has to offer for free for 30 days, visit brilliant.world/blackpenredpen or scan the QR code on screen, or you can click the link in the description and you will get 20% off annual premium subscription. I want to thank Brilliant for sponsoring this video, and I also want to thank you for checking them out.